Hi, welcome to youwillunderstandmath.com. Today I want you to understand how to fill in the unit circle. Here we have a completely filled in unit circle with all of the radian measures, degree measures, as well as the cosine and sine values on the outside. I want to show you how to fill in this unit circle from scratch. In just a second, you'll see a completely blank unit circle, and I want you to see how we get the radian measures, pi over 6, pi over 4, pi over 3, so on and so forth. And I will give you a formula to convert to degrees if you like before I begin. Notice here I have my completely blank unit circle, and as promised, let me show you how to convert into degrees first. For example, here I have the formula. If I wanted to know what the degree measure is given any radian measure, I can plug into this formula here. For example, if I wanted to know what is 2 pi over 3 in terms of degrees, I would multiply that by 180 degrees over pi. I can multiply straight across. 2 pi times 180 degrees would be 360 degrees pi. I know it looks weird, but the pi's will cancel in just a second. 3 times pi would be 3 pi. Now I may reduce. 3 goes into itself one time. 3 goes into 360 120 times, and that's still in degrees. Also, our pi's cancel out, as I just said. We have 120 degrees divided by 1, which is 120 degrees. There you have it. 2 pi over 3 is the same as 120 degrees. Now that we know how to convert between radians and degrees, everything I do in the unit circle will be in radians, but you can convert to degrees as you like. First, I'm going to fill in all of the angles which are multiples of pi over 4. The first one we have is this one, this angle here. This measures pi over 4. The next one will be this right angle. Okay, notice all of the warm colored angles will be multiples of pi over 4. The first one is this one whose terminal side is the red color. The second one is this one whose terminal side is the orange color. The third one is this one whose terminal side is the red color, and then the next one is the orange color, and the next one is the red, then orange, then red, then orange again. The first one is pi over 4. The second one is 2 pi over 4. The next one will be 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. As I said, this one would be 2 pi over 4. I did a little scratch work over here, so you see that 2 pi over 4, when you reduce it, is the same as pi over 2. This one will be pi over 2. In the same way, the next one will be 3 pi over 4. The next one will be 4 pi over 4, and I reduced this one over here. This is the same as pi, and so on. I filled in the bottom of our unit circle the same way as I did the top. Now I will show you how to fill in the multiples of pi over 6. Those will be the warmer colors, such as the light blue terminal side and the turquoise terminal side. All of the light blue and turquoise will be multiples of pi over 6, as well as the quarters, the pi over 2, the pi, the 3 pi over 2, and the 2 pi are also multiples of pi over 6. Let's get started. The first one will be 1 pi over 6. The next one will be 2 pi over 6. I've done a little scratch work over here. 2 pi over 6 is the same as pi over 3. This will be pi over 3. This is actually in a warmer color, but it's still a multiple of pi over 6. This one would be the same as 3 pi over 6, which I've done some scratch work here, and you notice it's still pi over 2. The next one will be this turquoise terminal side, and this will be 4 pi over 6. I've done the scratch work here. This is the same as 2 pi over 3. There you have it. I filled in the unit circle using multiples of pi over 6. This one was 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and so on and so forth. I've done the scratch work over here from pi all the way over to 2 pi. If you want to check the scratch work here, these are the reductions We have our unit circle completely filled in for all of the multiples of pi over 4 as well as the multiples of pi over 6. In the next video, I will show you how to derive the cosine and sine values using a shortcut. This time we will not use special right triangles, but nonetheless, we will be able to get the cosine and sine values at each angle in the unit circle.